All right, we continue on with balancing complicated half reactions, and this is going to feature E and F. And E is a bit strange, and you'll see why in a moment. So hydrogen gas becoming water. You can go, oh, look at the hydrogens, they're already balanced, but ignore that. We're going to go through the regular process. There are no other major atoms, ignore that. We have oxygen, so we know we have to add wah-wah. We have to add the water to the left. Now we're going to balance out our hydrogens. And we have to balance by adding two H pluses. That way we have 4 hydrogens both sides. Left side 0, right side's +2. So we had to add 2 electrons on the right to bring the charge down and get it all balanced. You can see that the electrons are on the right, they're on the product side, so we know that has to be oxidation. But this question said make it basic, so we're going to make it basic. Here we have 2 H pluses, so we got to add 2 OH minuses to both sides. Boom and boom. If I had 8 H pluses here, I'd have to add 8 OH minuses left and right as well. But since it's 2, it's 2 and 2. We know those are going to combine to make 2 wah-wahs. And then we say, hey, is there any canceling out we can do? And the answer is no. That is now a balanced half reaction. 2 and 2 is 4 H's, 4 H's, 2 O's, 2 O's. On the left we have a 2 minus charge, and on the right we have a 2 minus charge. Oh, by the way, I guess, did I write down that that's oxidation? All right, next beast, which is our final one. Chlorine becomes perchlorate, and it's an acid. And so we go and say chlorine's diatomic. And there's our perchlorate, which we can look up on our complex ions. Per means we actually have more oxygens in our ion. We'll get to that later. And this time we have to do a major. 2 Cl's, 1 Cl. So we have to put a 2 in there. Now, 2 times 4 is 8. So I have 8 oxygens on the right. So I have to add 8 wah-wahs on the left. Having done that, I see I have 16 hydrogens. So you know I got to put 16 H pluses on the right. The final thing is to balance the charge. On the left, the charge happens to be 0. On the right, I have 16 plus there. Take away 2 is 14. And so I had to put 14 electrons on the right to bring the charge down so that they're all equal. Now, it happens that this side's 0, and we brought this down to 0. Doesn't mean the sides have to be set to 0, but this left side must equal the right side. In terms of charge, electrons are on the right, so that's oxidation. So with 6 examples, you should have no problem attacking all kinds of questions. We're going to give you lots of practice at this, because you're going to need to be able to balance half reactions before you can balance redox reactions, which comes up next day. Hopefully it's making sense. If not, rewatch these videos. Make sure you have everything copied and get help if you need it.